the ID of the student, the ID of the course, and also the grade. This is my database, my tables that I'm going to use today. So I just create the table students, I put a primary key, I put for the name of the student to be not null, and also for the group. To be honest, I put that constraint because when I'm having a table and I have like as group all the time, my thinking is going to the fact that maybe there is a relation one to many. And if I want to add in what follows that table groups, if I define from the beginning this field not null, then I can do that. If not, I have to add too many constraints. I'm not going to table courses has the primary key and the credits just executing, and the exam is the intermediate table. It has the foreign keys of the table students and the table courses that are referenced, and also the primary key constraint that is set on the SID and on the CID. Okay, I'm going also to generate now a diagram, new database diagram. All the time it's a yes. I'm going to add my tables. As you can see, sometimes the refresh it's automatically, but other times no chance. Okay, so this is my relation. Yes, so I have the relation many to many. The primary key from the student SID is a foreign key in the table exams, foreign key in the table exams. Okay, do you have any questions related to the create table statements? I think no. Then, because I want to show you some results, I need to insert values in my table. If I don't have values, I cannot show you examples. I've told you yesterday, related to the values that you can insert. Insert into students, you have the name of the fields, and then you have the values. If you want to do like me, like not saying insert and put a value, insert and put another value, you can do like this. This is a tuple, then I have a comma, this is another tuple or another record, and in this manner I can have as many records as I want in my table. And very, very short. I'm going to execute this command. Okay, so I inserted 5 students, 3 courses, and 3 exams. Okay, let me show you what I'm having in my table. This is the first select that we have today. This is the most simple one. If we think about the structure of the select is the one that is going to show us what we have in our tables. If I'm going to have something like select star from name of the table, I'm going to see all the records that I'm having in my table. Select all the records from name of the table. I just wanted to show you my records. Usually it's good to look what records you have so that you can understand better the queries that we are going to have. So I have these students, these courses, and these exams. Okay, I'm going to start with the first queries. The first ones are going to be more easy. The select statement, it's something like select the fields that you want to select from that table, from name of the table all the time, where means you want to put a condition. For example, the students to have the age 21. Then you can have group by, having, this is a clause of the group by, and then you can have order by. We will take each of these elements step by step, but this was as a short idea. So my first query that you also have in that document, say to us, find all the 21 years old students from the students table. Definitely, I'm going to have select all, because find all, select star from my table students where the age is 21. Age is a column from my table. Okay, all the time when you put where or when you put here after select, you put name of the columns or arithmetical operations that can be done through those columns that you have in the table. Of course, that if we are going to verify this query, the result is going to be Razvan. Razvan is having 21 years old, and also Paula. She's having also, and also Alina. Alina is having 21 years old. I'm sorry, I don't know how can I do these results bigger. Only the queries I can have it bigger. So let me execute this query. And of course I have Razvan Alina and the age is 21. This is how you have to handle this query. More than this, you can see here an S. If you want to put an alias for your table, this will be. I put an alias from my table S. Uh, this alias is usually used when you work on multiple tables, because if you have the same name, the same column names, it's going to be impossible for the SQL server to know the table, the column is from what table. And that's why we usually use this alias. The alias is usually a letter that is put it to help us. But if you want to have it without that S, yes, it's also possible when you have a table or when you have tables that does not have columns with the same name. Okay, now I want to find the name and the email addresses of all the 21-year-old students from the student table. And also, I want to eliminate the duplicates. So, how I'm doing this? First, I'm going to show you the second one. Why? Because the select is very simple. Find the name and the email addresses. So this means that I'm going to select the name of the student. The name of the column is called as name, and also the email. The column is called email. So select as name, comma, email. From the table name is students, where the age is 21. The only difference is the fact that I'm not going to select all the fields. I'm going to select only the name and the email address. This is my result. Razvan and Alina, the same result. Okay, when do you use this distinct? This distinct is going to help you to eliminate the duplicates. If I was having here once again Razvan, sorry. Yes, I would have seen just the first Razvan, not both of them. But in this case, if I don't have duplicates, the result is going to be the same. So maybe you are going to try it with more records, and then you are going to see what happens. If we have time enough, I can find an example and show you that one. And also you can ask me on the laboratory. I have also this kind of queries in the laboratory for you to show you. Like
Sorry,
more
I have a
than,
question.
yes,
Distinct is only for the name or for the name and email as well?
is for the field, is for the name.
Okay, I get it.
Okay.
So if you wanted it to be for both, we should pair them with parentheses.
Or just
Uh,
write distinct again for email.
just write distinct in front
Okay.
of the column. You don't need to put any parentheses. You just need to put distinct in front. And to be honest, I'm telling you like this, usually this distinct is used when you display just one column, because the chance it's all the time bigger to have duplicates. But on the laboratory, yes, I have an example that is really showing you the distinct. Okay, now because I've told you about this alias, this S that I put here, I did it without that alias. If it's a simple table and I don't have duplicate names for the columns, just select as name email from students where age is 21. Okay, it's exactly the same result. As you could have already guessed, if you want to put comments, it's all the time line, and it's green. it's a nice green. Okay, so please tell me if you have any other questions until this point. Okay, if you don't have any other questions, I'm going to move on. And I'm going to tell you about these range variables. I already told you about this alias before. And these alias are needed when the same relation appears twice in a from clause, where more exactly to solve the ambiguity that can appear there. And I'm going to show you on examples these things. First of all, I want to find the name of the students who got 10 grade and the IDs of the corresponding courses. Just let me try to make it, yes, to see all the text of the requirement better. Okay, so all the time when you want to combine multiple tables, you need first to go and to check on the tables. Name of the students who got the grade 10 and the course to which these students got the grade 10. So I'm going to look here. I have this table students, but in my table students, I do not have the course ID. And that's why I need to make the connection between these two tables. If I'm going to do something like this, I'm going to execute just the first two lines. Select name and CID from students, exams. Why it's no need to access the table courses? Because I have also in this table exam the ID of the course, and more than this, in this table I have also the grade. So you don't need to go through all these tables. It's enough to use just the students and the exams. So I'm going to have select S name and C name from students exam E. Of course, my result is going to have a lot of records, and I am more than sure that you have guessed that is not correct. If I look of what I'm having here, this means that I have 15 persons that have participated to all the courses and got a 10. Well, let's be honest, that cannot be. It's not true. And that's why we need to do the relation between the tables. I need to show you what I'm having in my tables to understand which are the persons that are satisfying and which is the result that I want to get. My task was to check the students that got the 10th grade and the IDs of the course. If I'm going to check on the table exams, I can see that the grade 10 was taken at the course algorithm 1. And the student that took this 10 has the ID 1235. If I'm looking on the table students, this ID 1235, it's exactly Razvan. Okay, so not all the students got this 10, only the ones that are connected. This is very important. So this is how we can see what we need to obtain when we do a select. And now, what is the condition that has to be fulfilled all the time? The value of the primary key from the table that is part 1 of the relation should be checked to be equal with the foreign key that is part many of the relation. And when I'm checking this, all the time I'm going to obtain just the values that are equal, the values that are communicating one to another. More exactly, in my case, as I showed to you, the grade is 10 here, the course ID is algorithm 1, and the ID of the student is 1235. And correspondingly, I have here the student that is called Razvan. And if I'm going to execute this query, definitely the result is going to be Razvan. And the course is algorithm. And also the grade is 10. Is it quite okay? Okay, so I think it's okay. Related to this condition, because here was the problem. I need to put alias. Why? Because I have the SID also in the table students and also in the table exams. And if I write SID equal with SID, the computer is going to say there is an error. What SID are you talking about? And that's why we use this alias. Also, I could have said students.sid equal with exams.sid, but usually it's not quite nice from us to say students.exams. And use the entire name. And that's why we prefer to put an alias for the tables that we used. So this is the basic explanation why we do this. All the time the condition that we need to check is this one, primary key equal with the foreign key. Okay, so this is the other written, as I told you, with the entire name of the table, students.sid equal with exam.sid. Of course, that the result is the same. And this is all. This is this example. If it's not clear, please ask me so I can answer to your question. Okay, so I think it's okay. From your yes, please.
Will you be giving us this query?
If I'm going to give you this query,
Yeah, with the whole example.
all these queries are going to be in the file that I've showed you in the beginning. Are only copy pasted from there, and more than this, the text that was there is put it as comments so that you can have it. It's because the Teams does not allow me to move from a window to another. All the time I need to close the share screen, open another one. I prefer to put everything here and compile it from here. Okay, so all these are in that file. But if you really need my SQL, yes, I can give it to you. There is no problem. Okay, so if we move on, I want to discuss about the arithmetical expression and the like operator. Here we are going to use this as or the equal and also like. I'm going to start with the first one. If we want to execute the command, I will start with the last one and I will explain to you why immediately. I want to display the age of the student minus 18, and also the duplicate of the age. I don't have any reasons. Any reason. I just want to try arithmetical calculus. You can have any arithmetical calculus that you want, like these ones. My problem is that when I'm doing this, in the result, I'm going to have no column name, no column name, if I don't put a name for these values that I'm calculating here. If you want to have here a name for that column, but that name, it's just a name for the column of the result. It's not the column that will exist in your table. It's just something that you put there, not to have no column name. You can do this by using what was called here up as or with equal. Yes, because I'm not quite. As or equal. With other words, let me show you. I can have like age 1 equal with s minus 18 or 2 multiplied with the age as age 2. These are the two possible ways in which I can denote a column from my result. Let me show you. I will execute again both of them. Yes, you can see you have here age 1 and here you have age 2. And in the other was no column name and no column name. This is how it's going to look like. So this is how we use the as and equal properties. Now I want to tell you something about this like. If I'm going to execute the first query, this is the one from the seminar, from the PDF. The problem is that I don't have students that have the name starting and ending with B and having at least 3 characters, and that's why I change and I put to start with A and end with A, because I have person that satisfy this condition. Um, and I will show you exactly the persons that I have there. So what is the like? If I want to display some specific varchars, like the name of the students, and I have requirement like this one, start with a letter, ending with a letter, having a number specified of characters. I can do this by using the like. Like has two properties. If you want to replace one character, you should use underline. If you want to replace 0 or more characters, you need to use the %. So these are the only rules that you should take into account. When I want to say that the name is starting with B, definitely is going to be like this. I'm going to have B and then %, if it's just starting with B. If I want to contain the B, I'm going to have %B %. So somewhere in the middle or on any position is the B. If I want to end with B, I'm going to have %B. B is the last one. Then, if I want to have more than starting and ending with B, like here, B %B, I want to have at least 3 characters. I need to start counting how many I have. The B that is on the first position is 1 character. The B that is on the last position is the second character. The % is 0 or more, so it's not 3. I still need 1. And that's why I put this underline here, because the underline is going to replace me 1 character. First B, the first one, the underline, the second character, and the last B is the third character. Of course, I could have put it B % underline. It was, and then B. It was exactly the same. So this is how the like it's working like. Please tell me if you have questions. Okay, if you don't have questions, let me show you what I'm having in my table students. I have these students, and I need to display the students that have the name starting with A, ending with A, and having 3 characters. In my case, I have Ada, Razvan no, Monica no, Paula no, and Alina. Okay, so I have Ada and Alina. The age of these students is Ada has 20 and Alina has 21, if we check here. Okay, and that's why my result is looking like you have already seen. But because I want you to see also everything, I added the column name to be more clear. Ada 20, Alina 21. So these are the values. And the age 1 here is calculated. Age 1 is the age minus 18. So 20 minus 18 is 2. And double of the age, 20 multiplied with 2 is 40. Are only arithmetical calculus. It's okay?
Yep.
Okay, thank you. So thank you very much. So then I'm going to move on, and I'm going to tell you something related to the set operations. The set operations are the operations from the mathematics, the ones that we already know as the reunion, the intersection, and the except. I'm going to show you some examples and also some remarks that maybe are going to be useful. I'm going to display the ID of the students who are older than 20 and have a grade in Algorithm 1 course. So I have some conditions there. So I need to pay attention how I'm going to respect those conditions. I'm going to take the first part. Display the ID of the students who are older than 20 years old. Definitely it's going to look like this. Select the ID from my table students where the age is greater than 20. I think until here it's quite okay. And if I'm going to check here, it's the ID 1235 and 1834. Then I need to have satisfied the following condition, or have a grade in Algorithm 1 course. The name of the course can be found only, well, it's the ID. Algorithm 1 is the name, it's has algorithm, it's longer. If we look on the table, this algorithm 1 course is the CID, but this one can be found only in the table exams. And that's why I need to have a select from my table exam, select the SID, the students that have the ID, where the CID is equal with algorithm 1. So the second select is going to be from the table exam. So these are my results. The first select was returning to me, if you remember, like this. 1, 2, 3, 5, and 1, 8, 3, 4. The second one was returning to me the records 1, 2, 3, 4, and 1, 2, 3, 5. Okay? What I have to do with these two? Because I need the student to have the first condition satisfied or the second condition satisfied is like the reunion that we have from the mathematics. All I need to do is to put a union between these two selects. I'm just going to put the union and I'm going to obtain these values. 1, 2, 3, 4, 1, 2, 3, 5, and 1, 8, 3, 4. Of course that you are asking yourself, but there were 4 records because the first select was giving us 2 records and the second one was giving us other 2 results, 2 records. Yes, it's true, but when you use union, the union is also eliminating the duplicates. So here you can see better with duplicates. If you don't want to eliminate the duplicates, you have to use what is called union all. If I'm going to execute exactly the same select but with union all instead of union, you are going to see that you have here 4 records. So you are going to have 1, 2, 3, 5 twice, the first and the last. The first is from the first condition, the first select, and the second is from the second select. It's something like this. Is it okay until here?
Yes.
Okay. Yes. Okay, thank you. Next, I want to show you some errors that you can have when you use union. What you should pay attention, and not only at union. This error that I'm going to show you are going to be applied also to the intersect, and diff and except. To all these 3, a union, intersect, and except. All of them are respecting the same rules. All the time, the fields that you are going to complete in the first select and in the second select should have the same number and the same type. For example, the number, yes, it's satisfied in this one. I have 2 and I have 2 also in the second select. But if I'm looking on the type of these fields, the SID from here is the SID and it's an int, but the age from here, it's an int, and the CID from here, it's a varchar. I know that the CID of the course, it's algorithm 1. Yes, so it's a varchar. And if I'm trying to execute this one, of course, it's not going to work. The conversion error appear. Okay, so this is one of the rules that you should take into account. This is referring to the type. Also the same number of columns. I have 1 column in the first select and in the second I have 2 columns. Definitely is not going to work. All queries using must have an equal number of expressions. Now, if I'm going to, sorry, I don't know why I moved so down. Yes, I'm here. On the document, you have other examples for the intersect and except. I'm going to show you also those examples. But first, I want to translate this example that you already have seen here with the students that are older than 20 and also the condition that are on the algorithm 1. What happens if I put instead of union between these 2 conditions the intersect? I'm going to show you to understand the difference between them. Of course that the intersect is the intersect from the mathematics and the except is the difference from the mathematics. I'm showing you these examples because unfortunately on the next queries I'm not going to have a result so that I can show you. As you already could have guessed from the first select, I was having the IDs. I was having two IDs, the one with 5 at the ending and the one with 1-8. And from the second, I was having one that was the common one that was ending with 5, and also one that was ending with 4. The idea is that in the moment in which you put the condition intersect, you are going to need to satisfy both of the conditions. So it means that I need to display the students who are older than 20 years old and also have the course algorithm 1. Okay, so the conditions that you have need to be related with the end. So both of them should be satisfied. On the union, it's enough is if one of is enough if the first is satisfied or the second one. And on the except, it's something like find IDs of the student who are older than 20 but do not have a course algorithm 1. So the first part is satisfied but not the second one. So this means that I'm going to take the students in my case that have the age greater than 20 but do not have the algorithm 1. In our case is going to be exactly the student with the ID 1834. This is the result. Okay, so please, no. Let me show you the other examples. If you want to have other examples, maybe these are more relevant, but in my case, I don't have a value so that I can show you exactly. Find the IDs of the students who received a grade in both 4-credit course and a credit and the 5-credit one. So both 4-credit course and 5-credit course. So this is going to be like select the ID of the student from the exam and the courses, where the ID of the courses must be equal and also the credits should be 4 and in the second one should be 5. If we check on this diagram, I have the exam table and I have the course table. The field that is called the credits is not available in the exams table, and that's why I need to make the connection between these two tables. From this I can check the condition of the credits, but once again I need also to check that this course was associated with the exam, because if not, it's going to generate me all the possible combination, and that's not true because not at all courses were exams, only to the ones that have connection here in this table. That's why I need all the time to check that condition with the primary key equal with the foreign key. And of course, if I'm going to execute this one, the result is going to be nothing in my case. But if you try, you can also find examples in which it's going to work. And if I'm going to consider the same example, but this time I want to find IDs of the student who received a grade in a 4-credit course but have no grades in a 5-credit course, this is the except example. Let me execute it for you. Unfortunately, I don't have records that satisfy both of the conditions, to satisfy the first condition and not satisfy the second condition, and that's why this is my result. Yes, I inserted here some values, so that is going to work. So I insert two exams. I associated the student 1, 2, 3, 4 with the MIP2 and MIP1. And if I'm going to check now from my table exams and courses, you can check here. You can see here that you have the course that is having let me make it bigger. It's not enough. Okay, I have MIP2 and this one is having 4 credits. So I want to have I recopy the query. This is the query that we are going to execute. So it must satisfy the 4 credit condition. I have this one MIP2, but not the condition with the 5. So the course in which the ID of the course in which are 4 credits is MIP2, and the course in which I have 5 credits is MIP1. Okay, and if we check here on the other table the connection, MIP1 can be found on the student 1, 2, 3, 4, and the MIP2 can also be found on the student 1, 2, 3, 4. And if I'm going to execute my query, of course it's again nothing. Maybe I should have inserted only the first one and after that the other. The result is correct, and I'm going to tell you why it's correct, because you had exactly the same person on a 4 credit course and also on a 5 credit course, and that's why the difference did not show me anything, because I wanted to be on the 4 credit course and not on the 5 credit course, and that's why it's like is there. Yes, all the time when you try the queries, you have to check your tables and do the query such that the conditions be fulfilled, because if the conditions are fulfilled, then you are going to understand better if everything is satisfied and is good. Okay, please tell me if you want a break of, if you don't mind, I would like to be only 5 minutes, because we lost the first 5 minutes and to have enough time to finish.
Okay.
It's fine, yeah.
It's fine.
Okay. Okay, so we take a 5 minutes break.
Yep.
Okay,
Yes.
perfectly. I'm going to let this share screen open, and I'm going just to put myself on mute, and I'll be